I'll do the same problem using slices and shells. That will be the first one. Then I'll do an example where shells will work better. Then another example when slices will work better. And maybe you'll get an intuition where and which one method to use. Okay, so let me try. So we have a region bounded by region R is bounded by say y equals to square root and y equals to x squared. And now this region is rotated around, not sure which axis you want to rotate it around. If anybody has any preference? Volume of the solid. So again, we'll do it in two methods. We'll do it in slices and we'll do the shells. So I'm going to draw a region. So x-axis, y-axis. We're going to be referring to that picture for both cases. So square root and a parabola. Okay. Intersection point, x squared equals root of x. So x equals to 0 or x equals to 1, whatever your favorite way to find that. You can either eyeball it or, for example, square both sides. I don't know, x to 4 equals to x. From here, x to 4 minus x equals to 0, x times x cubed minus 1 equals to 0. So x equals to 0 or x cubed equal to 1. So should be able to figure out what our solution here, x equals to 0 and x equals to 1. So therefore our points becomes 1 and 1 because y equals to x squared, 1 squared is 1, and the over endpoint 0, 0. Okay. So we're going to be using that for our limits of integration. So we're going to be moving from origin 0, 0 all the way to point 1, 1. So x will be changing from 0 to 1, and y will be changing from 0 to 1. So in this case, there is not that much confusion. So if you will need to change x, it will be from 0 to 1, and y will be also changing from 0. We're traveling from point 0, 0 to 1, 1. So x coordinate start at 0, ends up at 1. Y coordinate start 0. Right? We'll do by shells because that's what thing which we did last time. So by shells. So 2 pi r h dr. R from that to that. From A to B, I guess. We can do shortcut if you like, because rotate around x-axis. We'll immediately know that r is likely going to be y, and height will be something in terms of x. Okay, so that's how our shortcut will be telling us. Now let's see how the picture drawing is going to help us figure out exactly what r and what h need to be in this case. Again, I draw the region, axis of rotation, Then I'm going to draw interval parallel to axis of rotation. And it's going to have two endpoints. Because we're staying on the same vertical distance from x-axis, we're going to share the same y. And one is a little bit to the right from over, so x right, whereas one to the right, and x left, one to the left. Mark the endpoints of this interval. Now I rotate that interval. Well, it's not going to be like interval because it's going to have some thickness in it. Then we see our shell. We see our shell. And on that shell, let's see, we see the radius and we see the height. So radius is going to be distance from x-axis to the interval. So it's a vertical distance, so it's y, as we already suspected. And height is going to be from your left point distance to your right point. So it's x right minus x. Again, that is something which we were predicting earlier, that h will be something in terms of x, and r is y. We're kind of ready to write down now our equation. So we're going to get integral 2 pi y x right minus x left dy, and y is changing from 0 to 1. As again, as we observed earlier, that limits for x will be changing from 0 to 1 and y will be changing from 0. All that is left now is figure out how to take care of that x right and x left in terms of y. So let's have a look. X right comes from this curve. An equation of that curve is y equals x squared. And actually that is y equals to x squared, right? Because we call that part is x right. And you solve it for x right. So x right equals to square root of y. That's what we're going to be substituting for x right. X left is the curve to the left. Curve to the left has equation y equals to square root of x. Actually, it's going to be square root of x left. Solve it for x left. Square both sides. So x left equals to y squared. And we take this and substitute for x left into our equation. So finally, we're going to get equation integral 0 to 1, 2 pi y, x right square root of y minus y squared dy. And that hopefully is easy enough integral, so we'll be able to do the calculations here. So we take 2 pi out, distribute y, and let me put that on the next page. Take 2 pi out. Integral still 0 to 1. Y times square root of y is y to the 3/2. Y times y squared is y to the 3rd. Okay. Then we take 2 pi. Y to 5/2 times 2 over 5 minus y to 4 over 4. And we do it from 0 to 1. Good thing about 0 is when you subtract 10, we get 0. So basically all that you have to do is to substitute 1. So again, a good thing about 1 is 1 to any power is 1. 2/5 minus 1/4. 2/5. Common denominator here is 20. 8 minus 5. So 2 pi times 3 over 20, reduce it, we get 3 pi over 10. get 3 pi over 10 if we did this problem by shells. Then now we do the same problem, but now we'll do it by slices. Because we rotate around x-axis, volume by slices is going to be equal integral from something to something, area of cross section. This is the area of cross section. And because we rotating around x-axis, dx. That's original setup. Now I'll do the drawing and I will confirm that that's what we expect to get. Okay. If I get a drawing and that's not exactly what matching to what I expected to get, then I will figure out where and how I did mistake. Okay. So now I'll do the drawing. Real region. We rotate around x-axis. Now when we do slice, we'll draw interval perpendicular to axis of rotation. Because we want to see slice. We want to see something which is flat. To get something to be flat, we want to have it perpendicular to axis of rotation. So we'll do this interval. Okay. When we do this interval, you notice that we have two endpoints and they're going to share the same x coordinate. One point is higher than the other point, so we're going to call one y top and y bottom. Okay. And now we'll rotate this. Now, if you look at the slice, okay. Firstly, to get slice, what we did, we're going to divide x-axis. So our dx, which you mark here, is going to be correct because we're going to be moving in Carpathian axis. But volume of slice. Approximately. We're going to multiply it by thickness, delta x. And because we see a washer, because we have to take something out, what we're going to be doing is we take area of bigger circle minus area of a smaller circle. So outer radius minus inner radius. Pi r squared for outer radius is going to be area of bigger circle, pi little r, it will be area of little circle. Now I need to express that big R and that small r in terms of coordinates of these endpoints. So you see that from here to here, that's little r, and from here to here is outside radius. So what you notice is its distance from x-axis toward your first point is little r. From x-axis toward your second point is outside radius. So because it's a vertical distance, so we're going to be involving coordinates, y coordinates of a point, so we're going to get pi y top squared minus pi y bottom squared. And as soon as we know that information, we try to write down our integral here. Integral pi y squared top minus pi y squared bottom dx, x changing from 0 to 1. We already discussed why x is changing from 0 to 1. All that is left now is figure out what is y and what is y top and y bottom. So y tops come from this curve. An equation of this curve is y equals to square root. And actually it's y top. Y bottom comes from that curve. An equation of that curve is y equals to x squared, and actually it's y bottom equals to x squared. So we're going to substitute. Pi square root of x squared minus pi x squared squared x. Okay. So I'll try to finish up on the next page. Integral 0 to 1. Square root of x squared is x. X squared squared is going to be x to the fourth. So we're going to get pi x squared over 2 minus pi x to the 5 over 5. We do it from 0 to 1. Then pi over 2 minus pi white. Should be 2 here, it should be 5 there. So minus pi over 5. Common denominator is 10. So we have 5 pi minus 2 pi. So we're going to get 3 pi. And that's exactly the same answer as we got earlier for volume by shells. So 3 pi over 10. So if you do calculations correctly, both ways, we should be able to get the same answer.